How the top-down problem solving method delivers from the bottom up? Oh, I hate this question. Top-down and breaks it down into its parts. Bottom-up uses a modular approach, starting with functions that link with each other to make a whole. It's 2 marks. They basically had to say top down is looking at the thing from the top and breaking it down. Bottom up is putting the pieces together and making it work. Briefly describe the following stages of the problems of the problem definition. How much marks for this by? 4 marks? 1 mark each? Jeez. Problem definition is getting an exact overview of the issues arising from the problem. I guess they're probably looking for issues arising because when you do a problem definition, you usually have to state the negative consequences that are happening because of the problem. Problem analysis is determining the inputs, processing, outputs, and the constraints of the system. This is like an IT paper, yeah. Identifying, this is choosing, coming up with multiple solutions and choosing the best one. Coming up with multiple solutions and choosing the best one. Implementation and review is writing the code and checking to see if it achieves functionality. A food court with 3 restaurants, 7 Jamaica and Barbados. Oh, there's a question at the time about that was long, which is a bunch of if statements. Okay, cool. How much space to give it to write it? Oh, not that much. Jeez, alright. A food court with 3 restaurants, 7 Jamaican, Barbadian, and Trinidadian cuisine has a single cashier. A separate bill is needed for each restaurant. Each meal is priced on the following table. Jamaican, $12 service charge, 4%. Barbadian, 10, 3. Trinidadian, service charge. Okay. There's also a sales tax of 10% and a discount of 5% if a customer buys more than 1 meal. Write the appropriate pseudocode for calculating a single bill for a single customer, assuming that there are variables called bill, menu option, and number of meals. There should be an option to exit the pseudocode. Something wrong here? Page 10. Oh, you tell me the black market scanner said, oh, the other page is just a bunch of lines. Let me not scan it in.
Emotional damage.
So how are you going for this answer here now? Alright. I'll have to write like on 2 lines. I'll have to double it up. Alright, so let's go. How much marks it is? Oh god, they didn't even put the marks. Alright, let me do processor elimination. This question had 2 and then 4 dice for 2 and 4 is 6. 6. So that means this question is 9 marks. 9 marks it is. 9. All your black marketers, come now, man. If we have space to write, give me space to write to now, please. I'm begging. I say it. I just say it. Alright. Alright, now we start by asking them what they want. Start. No, I had to declare variables first, sorry. I don't know if they're checking marks with variables, but we'll take it. The variables that we need is bill. Bill should be equal to 0. Menu option. Set that to 0 to number of meals. Look how long these variables are. They could be NOM, number of meals, 0. Alright. start. No, I have to put the start in between because I don't have space. Start. Right, so start. Print. Please enter. Why is it to open up? Just close. Close. Yes. My bad. My bad, y'all. I said yes, I'm sure. Okay, cool. Right there. Please enter number of meals. No. We can't enter the number of meals because we don't know how much meals they're gonna take. Right there, purpose of good for calculating a single bill for a single customer, assuming that there are variables called bill, menu option, number of meals. There must be an option to exit the pseudocode. Someone seen like 4 ways to do this. Let me think of the easiest way. Seeing that I only have 5 lines. I'm gonna look for efficiency. So the person is supposed to come in. They must have an option to exit the pseudocode. So that means you had to put a while loop. Please enter choice. Okay, please enter choice. 1 for Jamaican, 2 for Barbadian, 3 for Trinidadian, and 0 to exit. Right, cool. Read choice. Oh wait, no, I had to double up the space. Right, read choice. Read choice. Right, so then we read choice. And while choice is not equal to 0, do. Right, because we had to have the ability to exit. So if the ability to exit is not there, then you can't continue. So while choice is not equal to 0, do. If choice is equal to 1, I'll double up. I don't have enough space. I'll run out of space. If choice is equal to 1, then we had to do some calculations. Yeah, then bill, they have to get a single bill, right? All right, bill is equal to bill. And then we had to do some hard maths now. Bill plus, there's a sale tax of 10% and a discount of 5% if a customer buys more than 1 meal. So we could add the sales tax and all that discounting at the end of it on the final bill, right? So the individual bill is going to be $12. Bill is equal to 12 plus a service charge of 4% plus 1.04 multiplied by 12. Nice. Because they bought the $12 Jamaican stuff. Yeah. Right. Right, your proposal for calculating a single bill for a single customer, assuming that there are variables called bill, menu option, number of meals. Oh shucks, it's named menu option. I put choice. Oops, my bad. Menu option. You know they'll take away a mark for that. Menu option. Right, while menu option is not always. Right. Oh shucks, if I do any maths the long way, I had to put 4% by 12 to add it. 4% by 12, yeah. I should just do the 1.0 for one time. I'll do the 1.0 for one time because I'm feeling to be mathsy tonight. Normally I'll do the long way because I think it'll be easier for students to understand things all better, but that's okay. Right, so your choice is 1, then you do that. We had to create a number of meals. Number of meals is equal to num of meals plus 1. That'll increment the number of meals. So we deal with that. Right, that's one. Then if choice, I love it when people come here and be like, call me bro. I'm not your bro. Alright. Choice is equal to 2. Then bill is equal to bill plus, what's that number, way? 10 multiplied by 1.0, how much percent that is? 1.03. And yeah, the carry up number of meals. Actually, I don't need to carry up. I could just carry up number of meals at the end of all the ifs. Yeah, I don't need to do it for each time. Because every time you go in a while loop and you don't get 0, that's a meal. Okay, cool. Oh no, don't erase it. Shouldn't have erased it, but that's okay. Anyhow, next if choice is equal to 3, then bill is equal to bill plus 8 by 1.01. Right, and then once we finish all of those ifs, then we could say number of meals is equal to num of meals plus 1. Good. That means we went through a meal and they would have chosen one of them inside there. And then you had a print, please enter and read again, which I am going to legit copy and paste on top here. Duplicate and pull them right here. Print enter number of meals. Right, so we read the menu option again, and then we end that while. So that will loop forevermore, as long as the person doesn't put a 0, it will keep going. Right, so nice. So that will loop. He will calculate the bill for each one of them, multiply, and then the end while, right? So yeah. Alright, so for the people that say I should prompt for the number of meals first, that wouldn't make any sense because they wouldn't have any option to exit the pseudocode. The whole point is they should continue and then they will exit depending on whenever they are ready or whenever they are finished. If you prompt for the number of meals and you loop only for the number of meals, then the exit will be determined. It will be predetermined. Okay, so let me read it over. Make sure that we're not losing it. A food court with 3 restaurants, 7 Jamaican, Barbados, and Trinidad cuisine has a single cashier. A separate bill is needed for each restaurant. Each meal is provided as shown in the table. Right, the purpose of the code for calculating a single bill for a single customer, receiving the variables bill, menu option, and number of meals. Right, the menu option will be each one that they choose. And they choose Jamaican, then they will get a calculation. They choose Barbadian, they will get a calculation. Yeah, I think that. These are along the lines of the types of questions that they will ask. And for 9 marks, breaking each one of the restaurants into a separate. No, they could get 1 Jamaican and then it'd be like a 1 next Jamaican and next Jamaican and next Jamaican, and each time we'll just keep adding it up. Yeah, alright. Yeah, so I believe we're good there. From the end while now, you're going to get the bill and you have to do the sales tax of 10% and 5% if they buy more than 1 meal. So now you're going to say if number of meals, NUM of meals is greater than 1, then sales tax of 10% and discount of 5%. Whew. Then the bill now is equal to, bill be equal to bill minus 10% of the bill, 0.10 multiplied by bill plus, plus the 10% sales tax minus the discount. But the discount was come after they put the sales tax. Well, they put it in that order. Sales tax of 10% and discount of 5%. So I'll put it that way still. Bill minus 0.05 multiplied by bill. Whatever bill is at that point in time. So the number of meals is greater than 1. You do that calculation. And yeah, print your bills. Then print your bill is bill. Alright. Yeah, this is consistent with the type of questions that they ask. Alright, so let's see if we met all of their criteria. They said that you should write the appropriate pseudocode for calculating a single bill for a single customer, assuming that there are variables called bill, menu option, and number of meals. So we ask them for their choice. We ask them for Jamaican, Barbadian, or Trinidadian, or 0 to exit, which is basically the menu option. We read the menu option. While menu option is not equal to 0, do. Yes, because the only way that they'll be able to exit is if they put in 0. Choice is 1. If the choice is 1, you calculate what the bill will be for that. Choice is 2, you calculate that. Calculate that. And each time you keep adding the bill back to whatever. So they could choose any amount that they want over and over until they press 0. When they press the 0, it will end the while because they would have had the choice over and over. The number of meals would have kept adding up over time because they could choose it any amount that they want. If the number of meals is greater than 1, then you take that bill, and that bill will be the bill multiplied by 10%, which is the sales tax. So you add that to the bill minus the discount, which is 0.05%, 0.05, which is 5%. And then that will update the bill, and then print your bill as bill, and then stop. Yeah. Oh, I think that's it. It's definitely a 9-mark question. Definitely 9 marks. 1 for the variables and declaration, 1 for prompting on the outside, 1 for doing a while, and next 1 for the condition. Each one of the ifs will be 1 mark, so that'll take me up to what? 1, 2, 3, 4, 5, 6, 7. 8 for doing the if, 9 for doing the calculation. Yeah, 9 marks. Anything else? You do too much. This is almost like the question where they ask about the bananas and the finding the winner of a vote, where they get multiple things to vote and you have to keep adding it up and then say the answer at the end. There's always a loop, and then the loop has to have some if statement at the end. But the restaurant thing, see this part here where they saying each bill is a separate bill is needed for each restaurant. Yeah, that is things to set up people. Because if you say a separate bill is needed for each restaurant, you might think that you have to do the code for each restaurant, but then they basically tell you here what they want, which is not the code for each restaurant. They just wanted the code for a single bill for a single customer. If it was the code for each restaurant, then you would have a different calculation, because every time you get Jamaican, you'd have to find a Jamaican bill or some kind of thing like that. All right, 9 marks. That was what I heard is that was the hardest question on the paper. Okay, pause. This is future me talking to present you, and I need to let you know something before we continue with this video. This question here, question number 3, part C, this question here that we're talking about right now, this question with the sales tax and the calculations of the different restaurants and whatnot, had a lot of controversy, it seems. A lot to the point where teachers were messaging me, asking me if my solution is correct and if they interpreted it differently and all that kind of stuff. So after the marking process was finished, I contacted and I spoke to different markers who mark computer science at the Cape level, and they said this question caused so much drama to the point where everybody was coming up with different solutions. So apparently there were 3 different solutions for this, because this question could have been interpreted in 3 different ways, which is why there was so much problems with students, and a lot of students complain about this question. So I checked through and I got one of the solutions from them. Well, I got the 3 solutions and I saw that the 3 solutions, this was one of the solutions. This was actually the shortest solution. So I did kind of do the right thing of choosing a solution that makes the most amount of sense with the most amount of marks. The other solutions were very, very long, and what they had to do was stretch out the marks a lot to get the 9 marks. But this one here was the closest to the 9 marks. So if you do come across the other solutions, your other solution may be correct. But what I know for sure is this one is correct. So if you use this answer and you understand the interpretation of this answer, that's cool. If you interpret it a different way, that's all right, guys. That's all right also. All right, good. So back to the rest of the questions. State which of the algorithms above illustrates unbounded iteration or unbounded. This is a repeat question, right? Unbounded is algorithm 1. Because it depends on the value of A to stop. A is inputted by user. Explain how the looping algorithm 2 is expected to terminate. Well, when X reaches 15. For 1 mark, kids. Yay. So this is me, future, letting you know that when I had the paper, I had question 4A and then it jumped straight to 4C. There was an asterisk question in between there and it didn't have it. So I'm going to jump to a clean answer sheet now and work that out for you. All right, so we're on to the clean paper now, and here is the question this is the question, part B. Trace through the execution of the following algorithm and draw the output exactly as it will be generated. Classic stars question. So let's put this in, and my video editor will get it in as neatly as possible. All right, trace through the algorithm. So it says, right, so what do we have? We have a I and a J, right, as integers. While I is less than or equal to 4, so that means this is going to go from 1 to 3. Yeah, because if I is, so I'll draw it on the side here because it'll be a little easier for me instead of having to scroll up and down to draw it. So if I mod 2 is equal to 0, that means only the even numbers, then print $. So this is one whole while loop that is going to go 3 times. So for the 3 times that the while loop is going to go, it's going to go I is 1, 2, and 3, and 4. 4 times, sorry, because it's less than or equal to, right? So that means it's going to run 4 times because they set I as 1. J didn't set it as anything, so we don't know what J is going to be, so let's go. If I mod 2 is equal to 0, 1 mod 2 is not equal to 0, so we don't do this part here. We do the else. The else is going to begin for J is 1 to 4, print stars. So we're going to get 1, 2, 3, 4 stars, right? Because that is what we had to do this here. And if new line, I is equal to I plus 1, so I goes up to 2, right? So now we're going to check to see if I mod 2, 2 mod 0 is equal to 0, yes, correct? So we have to print, no, they did say print new line, so once it said print new line, that means our next location is going to be right there, right? So I'll put in a little dot to let you know that that's where the next thing is supposed to be. After the print new line, I goes up to 2. 2 mod 0 is equal to 0, so we have to print a $sign here. And then 4J is 1 to 4, print stars. So this is going to print 4 stars. 1, 2, 3, 4. Right, and then we go again, which will print new line. Well, the end for will finish, right? So we just finished the if part of it. So we won't do the else. The print new line is going to print a new line, and we're going to start down here. And then I is equal to I plus 1. So I goes up to 3. 3 mod 0 is not 0. 3 mod 2 is not 0, it's 1. So we have to do this part here again, which is J is equal to 1 to 4, print stars, so we print 1, 2, 3, 4. And then we print new line, dot goes down here, we go back up, we reach to 4 right now because I has now gone to 4. I goes to 4, I mod 2 is equal to 0. Yes, it's correct because it's an even number. We print the dollar sign here, and then we do the 4. 1, 2, 3, 4. I goes up to 5, and the while loop will now stop, and then we're done. So we should get something like 4 stars, a dollar sign, 4 stars, 4 stars, a dollar sign, 4 stars. And that should be the answer for that. How much marks is this? 6 marks. All right. I think that should be 1, 2, 3, 4, 5, 6. Yeah. So 1 mark for each line, I guess. They'll give 1 mark, 1 mark, 1 mark, 1 mark, and then the other 2 marks will be for putting the dollar signs in the correct place. So if you just had 4 stars, I guess they would give you it like that. I would like to assume that my answer is correct. And let's see. I think that makes sense. That makes perfect sense to me. All right, so let's move on. Part C, the following algorithm is designed to print a table of cubes of all the even positive integers between 4 inclusive and 14 inclusive. However, there are errors in the algorithm. I is 4 while I is less than 14. All right, let's start off by saying line 2 is a problem. It should be less than or equal to. So this will be while I less than or equal to 14. Then line number 3 should be assignment statement wrong. So it should be cube is equal to I multiplied by I multiplied by I. And then print I on cube. It's supposed to print a table of cubes of all the even numbers. If it's an even number, it should be in line number 5. It should be wrong count. It should be I is equal to I plus 2. Yeah. Because if it's even numbers, it should be I is equal to I plus 2. If you put mod 2, it'll be like, it should be okay. So I mod 2 equals, no, don't try to do that mod now. You'll end up changing the whole algorithm. So take what they give you and work with that. If you try to do that mod, you have to say if I mod 2 is equal to 0, then do the cube. That's surplus to requirements. So yeah, let's go up by 2. Your life will be easier. That is all for module 2, boy. Oh, must be nice, must be nice.